In the previous video, we learned how to reduce dynamic dispatch to improve our application's performance. In this video, we're going to measure the differences between reference types and value types to gain an understanding of how the two perform. In video 4 of section 1, we discussed classes, structs, and enums, and illustrated some of the differences between reference types and value types in theory. We further developed this conversation in videos 2 and 3 in our section on memory management, where we demonstrated how we can assist ARC in eliminating reference counting overhead. In this video, we'll measure the impact of reference types over value types using XCTest. The more mindful we are about the programming choices we make, the more optimized our code will be. In Xcode, create a new single-view application and make sure you include unit tests. Once your application is loaded, add a new file and name it whatever you like. In this new file, we're going to create two simplified versions of int, one as a class and one as a struct. We'll also need to overload the plus operator to handle our new types. Create a class and name it referenceTypeInt. We'll give it a single property named value, which will hold a Swift int. We'll also create a simple initializer, which will take an int. Now, for our struct, we'll simply copy our class and give it a name of valueTypeInt. Next, we'll paste in our overload for our plus operator. This is a fairly common overload of the plus operator. The way this works is that our left-hand side parameter represents the object on the left of the plus operator, while the right-hand side parameter represents the object on the right of the operator. We simply return a summed version of the object by passing the sum of the addition into our initializer. Once again, we'll copy and paste this for our value type and make the necessary changes. Okay, this is enough to run our tests. Open your test class and we'll remove everything we don't need. We'll create a test function named testReferenceTypeInt and we'll add a call to our measure block. We'll define a variable named refType and give it a value of referenceTypeInt and pass in an initial value. Then we'll create a for-in loop that iterates through a range between 1 and 1,000,000. Inside of our loop, we'll give our refType a new value by adding refType to a new instance of referenceTypeInt in which we'll pass our index. Let's go ahead and duplicate this method. We'll make the necessary changes to test our value type. And with that, we can run our test class by clicking the diamond in the gutter next to our class. The test's complete, and we see our class operation took a little over 0.2 of a second, while our value type operation took about 0.008 of a second. This is a pretty substantial difference already that illustrates the power of immutability in a Swift language. Let's set the speed as our baseline and then rerun our tests with whole module optimization turned on. I'll navigate to my project's build settings and switch it on. And then I'll head back over to my test class and run the operation again. With whole module optimization enabled, the compiler is able to further optimize our value type, giving us a 20% boost in performance, while our reference type only receives about a 5% boost. I should note that this is a really primitive test that was designed to clearly polarize the performance differences between classes and structs. With more complex structs, especially structs containing mutating functions or references to other classes, the performance gaps in our tests would be much less severe. In this video, we demonstrated the difference in performance between reference types and value types in Swift. In the next video, we'll discuss how whole module optimization can optimize the performance of generics.